Good morning, everybody, and welcome to the world of batteries, as Avnet sees the world of batteries. We're going to spend just a few minutes this morning talking about the product range that Avnet has for battery products, and we're going to spend some specific time talking about how to choose a lithium battery. Mark and myself, we spend our whole lives talking about battery products, and 95% of the time we talk is about lithium products, so that's what we're going to focus on this morning. So what does a customer typically want from a battery? Well, this is the fantasy world of a customer looking for a battery product. They want a battery that is totally safe. They want a battery that's as small as possible. They want a battery that's as light as possible. They want a battery that's got the highest possible capacity. They want the battery at the lowest price. They want a battery with a long calendar life. They want the most cycles out of the battery. They want it to be a highest discharge possible, but they don't want that to compromise on the capacity. They want it to be intelligent if possible. They want it to have the widest temperature range. They don't want to pay for any approval costs. They want it available from stock as a standard item, and they want to be able to get it from a number of different sources. They don't want to be single sourced. So this is the fantasy world. It doesn't exist. There is always compromise when we're talking about battery products. But we're going to tell you a little bit about what Avnet has in terms of batteries. There is nothing particularly new in terms of chemistry on battery products. What we have now is what we had probably 20, 30 years ago in terms of chemistry. Everybody is looking for the new technology. There are thousands of very well-paid engineers across the world looking for the new chemistry that is going to make the revolution. But so far they don't find it, and we're not sure that anybody will find that particular chemistry. So we have the standard battery chemistries: alkaline at 1.5 volt, lithium at 1.5 volt, lithium at 3 volt, and lithium primary at 3.6 volt. Then on the rechargeable side, we have lead acid, 2 volt cells, we have nickel metal hydride, 1.2 volt cells, and we have lithium ion, lithium polymer, 3.6 volt. That is the range of chemistries. It hasn't changed very much in the last 20 years. And it's not likely to change much in the next 10 years either. There are 5 different types of battery depending on the application. So the first type is commodity products. So you would recognize these as being alkaline cells, AA, AAA, used in remote controllers, typically, or you would recognize them as CR2032 coin cells used in weighing scales, watches, that sort of application. So that's the commodity product. Then we have primary lithium products, which at 3 volt is the typical voltage. And these are particularly used in the new emerging IoT applications and becoming really very important. You have standard lithium ion, lithium polymer products that are available. We've done this because nobody wants to pay for approval costs. Everybody wants something they can get off the shelf immediately. And that's why we have a range of 65, 70 standard lithium ion, lithium polymer packs easily available to customers. We also have unique designs where a customer will have a requirement for particular cells with particular electronics in particular plastics, and we will design a unique bespoke battery pack for them. And then we're looking for the new products in the market. It's not new chemistries, it's different sizes using the same chemistry, but particularly with the hearables, wearables markets developing, these are the products which everybody is looking for. And as far as Avnet is concerned, we work with brand name manufacturers for each chemistry, so we work with the experts in each particular product family. So let's take a look at the primary batteries to start with. Lithium manganese dioxide. These are 3 volt products, and they are particularly used in IoT applications. 2 basic different styles of lithium manganese dioxide, the bobbin style and the spiral style. One is for long life and one is for high pulse discharge. So if you look at the difference between the two styles, we have a bobbin style that is maximized for long life. So if you have an application where you want to put a battery into a piece of equipment and it's going to last 20 years in the field, that is when you would start using a bobbin style lithium thionyl chloride. If you want a thionyl chloride or a lithium primary cell that is used for pulses, high pulses, for communication, that sort of application, then you would use a spiral version. But neither of them is perfect because one is maximized for long life, the other one is maximized for pulses. So what do you do if you want both? Well, that's when you use a combination battery. You have a lithium thionyl chloride standard cell that gives you the long life, but you combine it with a lithium ion rechargeable cell, which is it's much more like a capacitor. So you take a standard lithium thionyl chloride, which gives you maybe the 20-year life, but for the pulses, the reason it's got 20 years life is because the rechargeable lithium ion takes care of all the high pulses, so you're not draining the battery. So if you want a combination of long life with high pulse communication, that's when you would use something which is a combination battery like the Tadiran Pulses Plus. So we very often get asked by our customers, why do you ask so many questions? Well, first of all, they ask, what questions should I ask and why are there so many of them? And the answer is, well, look, we can give you a quick answer on your battery requirement or we can give you a good answer. Everybody really wants a good, quick answer. So the more questions we ask at the very beginning, then the closer we get to having the right solution as quickly as possible. So there are some general commercial questions. What's the application? How many? What are your project timescales? What are you expecting to pay for the battery? And how long do you want your product to be in the market? General commercial questions. Then we have physical questions. How much space do you have available? Do you want a bare cell or do you want it with tags? Do you want wires on it? Which tags? How many wires? Which connector? And then you have the electrical questions. What is the battery voltage you're working to? At what voltage will your system cut off? So the battery under discharge, the voltage will drop. And obviously you need to keep the voltage above the voltage system of the electronics. What is the minimum capacity? How long do you want it to last? What are the background discharge requirements? What pulse profile do you need? What's the pulse current? How long does it last? How often is that pulse current going to take place? Most importantly, what's the temperature profile? Batteries hate hot temperatures, they hate cold temperatures. So we need to have an estimate of the temperature profile. What temperature is it going to work at and how long is it going to be working at that temperature? And do you need, at the end of the battery life, do you need a clear indication of whether that battery is going to fail? And then we have the subject which everybody hates, and that's approvals. What approvals do you need? Who's going to pay for them? Questions which have to be put into the decision on any particular battery. So that gives you an overview of our primary batteries. And I'm now going to hand over to Mark, who's going to talk to you about the lithium-ion rechargeable products.
Well, thank you, Tim, for the introduction on primary batteries. So I'm going to talk to you about rechargeables. So the most common battery chemistry in rechargeable battery technology, especially in portable equipment, has become lithium-ion batteries. Why? Lithium-ion batteries offer the highest energy density, so that means you get most energy in the smallest packaging, lowest weight, available from the standard chemistries available in the market. But a lithium battery is not same as the other. So there are different types and shapes of lithium batteries. So we get cylindrical cells, we get prismatic shapes. So most common is in various applications the cylindrical size. That's the highest production capacity and used in all kind of applications. So as you can see here, we have cells made for the e-vehicles market, for power tools, for e-bikes, but then also for consumer electronics, which means absolute highest energy requirements compared to different requirements, for example, by power tools or automotive, which request high peak discharge but also high constant discharge. And therefore, there are different chemistries available in lithium-ion chemistry to deal with these individual requirements. And yeah, they're all in the common standard size called 18650. So that's where the majority of the market is, and where it will be in the future as well. With regards to a prismatic shape, so if I just can't deal with 2 centimeters height, there are prismatic cells, and most common now is the lithium polymer chemistry, and this, it looks like a thin, flat shape pouch cell, where the main difference is, of course, the way it is manufactured to lithium-ion batteries. So both chemistries do offer 3.6 or 3.7 volts nominal voltage. But another main difference is the way the electrolyte is made. It is not liquid electrolyte. It's kind of gel or polymer electrolyte. And one advantage of this technology is that you can get it into the shape you want. So while with the cylindrical cells you're always stuck with that cylindrical size, you can tweak the design and get a tooling made for a lithium polymer in the size you want it. That's why the whole consumer electronics market is moving into this technology on laptop computers, on mobile phones. It's the most common technology now because you can use the available space as good as possible to get the maximum capacity in. It's not necessarily a high discharge chemistry.
So I think it would be worth just talking about the lithium-ion cylindrical cells and talking about market trends, particularly in terms of capacity in an 18650 cell, and also the changes in size from 18650 to 21700. So perhaps, Mark, you can just talk about that a little bit.
Yeah, well, 21700 is another size that has been brought to the market mainly due to the power tools market, because they want to get more capacity in a limited space, so they can't just put more cells together. They have to increase the cell size. And there are some trends in the market that this will be the new standard, maybe, but at the moment we can't really see it happening in large scale. So for the moment, 18650 is still the major size available, but this is something we are monitoring closely to see where the market is going for 21700. Yeah. So Tim.
So if you there is a danger when you're talking about batteries that we talk in our own language. Okay, so it may well be that people this morning don't even know what 18650 means. So 18650 means that the cylindrical cell is 18 millimeters diameter and it's 65 millimeters high. That's why it's called 18650. It's been around for, say, 20 years now, and that has been the standard part. And up until about 3 years ago, nobody was going to change that. But then the e-vehicle market came along and they demanded a different cell with higher capacity. Don't change the size too much, but give us much more capacity. So at the moment in 18650, 18 millimeters, 65 millimeters, the biggest capacity is 3.35 ampere, and that's about as far as it's going to go. But that was no use for e-vehicles. They wanted more capacity, so they said, right, change it to 21700, which is 21 millimeters diameter, 70 millimeters high. So not a huge difference, but the difference in capacity is very significant. So the maximum from 18650 is 3.35 ampere. The maximum from 21700 is now going towards 5 ampere. So you get significantly more capacity for not a great deal of increase in space and size. So we believe that that will happen because where e-vehicles lead, the market tends to follow. So within the next 5 years, we believe that 21700 will be the standard part as opposed to 18650, which is what it is right now. And with rechargeable, you have the same set of questions that you have with primary. What's the application, the quantity, the project timescales, the target cost, the life of the product? How much space? What is the weight restriction? Is it fixed? Is it in plastics that you can remove and recharge, or is it fixed inside the equipment? How many wires, which connector? What's the voltage? What's the system low voltage cutoff? What capacity do you need? Do you need other functionality? Do you need fuel gauging? Do you need sophisticated intelligence? What is the power profile? What's the temperature profile? How many cycles do you need? And what is your calendar life? People tend to get confused between cycle life and calendar life. People tend to say, I want at least 300 cycles, 500 cycles, and I want it to last 10 years. It's fine, but after 5 years, you will find that the chemicals start reacting and the cell dies anyway. So there's no point having a battery that's targeted for 10-year life, because it will start dying after 5 years. And then the approvals. Who's going to pay for them? What do you need? Where are you shipping? What's the product? Which battery are you using? All those are really essential when you're talking about approvals to make sure you can ship your product safely and legally. So that's a very quick overview of the avnet capability on batteries and where we start looking for a lithium solution. But if we go back to the second slide that we showed, when we first started this, we talked about the ideal battery. We talked about a battery that needs to be totally safe, as small as possible, all the other things that a customer ideally wants. But designing and choosing a lithium battery is a consultation. We have to sit around the table, look at everything to do with the battery, and then decide which is the right solution for any particular application. So that's us. That's Avnet, that's batteries, that's Mark, that's myself. If anybody's got any questions, we'd be pleased to take them.